Hello everyone, my name is Forrest Schwartz, and I'm here to present you today the physics lecture video I went to. I went to the lecture about why eggs harden when they're heated while most materials melt, and I found this lecture particularly interesting because, I don't know, you expect most things to melt when heated. That's the way we've grown up learning things like ice and metals and all sorts of other materials, so why does an egg harden? And do other things demonstrate the same property? Well, when they went into the video, here's a quick video of eggs being cooked. Hopefully you can sort of see them hardening. It's kind of hard to tell in this video right here, but I'm sure if you've eaten eggs before, you know that they harden when they're cooked. But anyways, so what is the reason behind this? I found mostly what he explained this video. It was mostly chemistry based, not as much physics based, but there are some physics concepts such as stress over strain and the elastic modulus. This is mostly stuff that we learned about first semester, or physics 1. But anyways, they're still interesting concepts, and here's a graph of the stress over strain, Young's modulus, etc., etc. So let's get down to it. What is the main reason behind this? And it all comes down to what makes up the egg. The egg is made up of proteins. And what are these proteins? They're a series of complex compounds. These compounds form long chains, and we call these chains polymers. So what's so unique about them is, as you can see, there's really long chains of molecules. So basically, when they're cooled, they kind of look like spaghetti. A little picture right here. They slide past each other. They don't really get too entangled, yada, yada, yada. But as you start to heat them up, these polymers start to expand. And when they expand, they stretch out. And because there's so many links in them, they form little links between the other polymers as they expand. And these are called cross links. So when these links are formed, they latch onto the other polymers, and as they expand, they stretch out. This stretched region becomes a stiff, stretched region, and it's hard to get back to the original shape. So this is what hardens the polymer. So once these crosslinks are formed and the polymer stretches out, the material is hardened in certain areas. It doesn't become completely hardened, because then it would be considered a crystalline structure, but there's short range order of hardening and formations that form. A lot of this stuff is covered in material science, if you guys have taken material science yet. So I found this lecture interesting as well, because it's a lot of stuff that I actually knew about, whereas the other lectures were a little more difficult to understand. But I know it's quite interesting how we got to apply the stuff that we've learned in material science and physics, the concepts of stress and strain, and the concepts of polymers to the real life, and why eggs tend to harden when heated. And this isn't just eggs, it's a lot of polymers. In the lecture, he talked about xanthan gum, and there's certain materials that you can apply to thicken water and other materials up, and it all comes down to basically the polymer-like structures and the way they interact with each other. But thank you very much. I hope you guys enjoyed my video. I'm sorry if the quality wasn't too good, but I hope I gave a good general explanation of the concepts behind everything. Have a good day. Bye.